So we can also prove triangles are congruent with the SSS congruence theorem or congruence criterion. So SSS stands for side, side, side. Three sides. If you know all three sides of one triangle are congruent to all three sides of the other, then the triangles are congruent. So if you know all three sides, that's enough. Just like on the others that we've learned, if you have two sides in the included angle or two angles in the included side, you can also just have all three sides. So from the information that we're given here, AB is congruent to DE, AC is congruent to DF, and BC is congruent to FE or EF. So we have all three sides in the first triangle congruent to all three sides in the second triangle. They are congruent because of the side, side, side criterion. But let's talk about rigid motions. To get them to match up, angle D, which is between, angle D has to match up with angle A. And then C is going to have to match up with F up there. And then B, the third side, is going to have to match up with E, that third angle over there, the third angle over the third angle. So in order to get that to match, it's a little bit of a, looks like a reflection. We're going to have to flip it a little bit, maybe even rotate it. Without it being in the actual coordinate grid, it's a little bit tough to figure it out perfectly, but we do know that we'd have to flip it. So if we had a reflection across that line right there, could reflect C up to there. And then it would just be a, mostly just a translation. It's a little bit of a rotation in there also. Just a slight rotation and then slide it in. So you could say you could reflect it over the line AB. And then there's just a little bit of a rotation counterclockwise. Not very much, probably like 15, 20 degrees. And then translate to the right. So to prove the triangles are congruent, we just need all three sides to be congruent to the other three sides. So we've got 1.7. Congruent to the 1.7. 2.3 is congruent to 2.3, and the 2.4 is congruent to 2.4. There's a little bit of a reflection in there. Maybe a little bit of a rotation as well. Mostly reflection, it looks like. So yes, they are congruent because of side, side, side. We've got side AB is congruent to side DE. We have side AC is congruent to side DF. And last, side BC is congruent to side EF. So the three sides are congruent to the other three sides, so that's side, side, side. You have the same thing going on in this other picture here. The 12 is congruent to the 12, the 24 to the 24, and the 20 to the 20. We have all three sides congruent to the other three sides, so that is side, side, side. You can list out the three sides again. So that means that side DF is congruent, no, not DF, D, that's a H there in the middle. DH is congruent to FH. GH is congruent to EH. And ED is congruent to GF. So the three sides are congruent, so that is side, side, side. So you can use side, side, side. So a couple more triangles down here. Prove that they are congruent or explain why they are not. So the 54 matches the 54. The 38 matches the 38. There's a problem. 28 does not match 32, so they are not congruent. And then for this last example, KJ matches up with LJ. KJ is congruent to LJ. KG is congruent to LG. And then they share the side in the middle. Since it's in both of them, you can say that JG is congruent to itself. JG. That's the reflexive property that we know that that's congruent. So that is enough to show that they are congruent because it's side, side, side. We can also apply side, side, side to real life examples like this. We've got this pendant. We can use it since they are to be congruent triangles. We've got 3 and 3. Those are all congruent. That means that this other side down here, CB and KL, need to match up. So in order for them to be congruent, they need to have the same length, which means they need to be equal. So 4x minus 6 has to be equal to 3x minus 4. Subtract the 3x over to get our x's together. You get x minus 6 equals negative 4. Then add the 6 over to get x by itself. So x equals 2. So if x equals 2, then we have enough to show that they are congruent because of which triangle congruence theorem? Because of side, side, side. You have all three sides of one triangle congruent to the three sides of the other triangle. Similar question, what value of x would allow us to use the triangle congruence theorem? So the 4 matches the 4, the other 4 matches the other 4. And then this side down here, 3x minus 11, would have to match up with the other side, which is 4. So if we have our equation right there, 3x minus 11 has to equal the other side, 4. add the 11 over, and divide, so you get x equals 5. And again, it says which triangle congruence theorem can you use? And again, that would be all three sides, congruent to all three sides. So that is side, side, side. Another similar question, but this time there's an x and a y. So we have a 90-degree angle and a 60-degree angle. Since the three angles always add to 180 degrees, we can add 90 and 60, that's 150. Subtract that from 180 to get that this third angle here is 30 degrees. So if that's 30 degrees, it has to match up with the other 30-degree angle, which means that the 7y plus 4 has to match with the 60-degree angle. So that's an equation. 7y plus 4 has to match with that 60-degree angle, so it has to equal 60. So subtract the 4, you get 56. Divide by 7, you get y equals 8. Now we need to solve for x using the other, making another equation here. So that 8x minus 12 has to match up. That would match up with the 12 centimeter side right there. So that's our equation. 8x minus 12 equals 12. Add the 12 to both sides, you get 8x equals 24. And then solve by dividing by 8. You get x equals 3. So then we would have these sides congruent. We have a 90-degree angle here and a 30-degree angle. 90 degrees, 30 degrees. We have the side in between. So which triangle congruence theorem is that? We have two angles with the side in between. Two angles, the side in between, angle, side, angle.